Introduction. ftir spectroscopy, one of the measurement techniques for collecting infrared spectra. Infrared light passes through the sample to produce interferogram or measured signal. Nearly all molecules containing covalent bonds will show some degree of IR absorption, except diatomic molecules such as hydrogen, nitrogen, and oxygen. By passing IR radiation through sample, frequencies absorbed can be observed and deduced to what type of chemical bond present in the molecule. There are two fundamental types of molecular vibration. The first one is stretching, involves continuous change in interatomic distance along the axis of the bond between the two atoms. And the second one is bending, characterized by change in the angle between two bonds. This is the example of ftir emission that we use in this experiment. Thermonuclear 380 ftir, and it costs around $6,000.
Next one, which is the procedure of Fourier transform infrared spectroscopy (FTIR) experiment. Sample preparation is to prepare the KBR palette of an organic compound such as benzoic acid, which we are using. For the KBR method, first obtain a sample benzoic acid and the KBR solid from the desiccator. Weigh about 1 gram of each and dry in the oven for about 2 to 3 hours at 110 degrees Celsius. Remove the agate mortar and pestle from the desiccator or use to clean the benzoic acid in KBR. Take about 1 mg of benzoic acid and green by using agate mortar and pestle until the benzoic acid become very small and shiny. Take 80 mg of KBR and green it using agate mortar and pestle until it becomes powder. Mix the benzoic acid and powdered KBR in agate mortar for ratio 1:80. Using the spatula, scrape the mixture into the middle and green the mixture again for about 1 or 5 seconds to mix the benzoic acid thoroughly with the KBR. The benzoic acid and KBR will be finely ground or the mixture will scatter the infrared radiation excessively. Heat the mixture in the center of the agate mortar using a spatula. To make the KBR pellet, remove the die set from the box or storage container. Clean die set with ethanol. Put the mixture of benzoic acid and KBR into the die set. Make sure the mixture fills the surface of the die set. Tightly close the die set and put it into hydraulic press gauge. Tighten the hydraulic press gauge. Press the hydraulic press gauge until the pressure goes up to 7,000 psi. Release the air and let it rest for about 2 minutes. Press the hydraulic press gauge again until the pressure goes up to 8,500 psi and let it rest for about 1 minute. Release the pressure. Then slowly remove the die set from the hydraulic press gauge. Open the die set and the KBR pellet that you obtained should appear clear like a piece of glass or transparent disc. Then put the KBR pellet into a pellet holder for the analysis. Next, for the sample preparation of FTIR, which is the reflectance. Run the spectrum of benzoic acid using the reflectance method. Lastly, obtain an unknown from your instructor for solid or liquid or powder and run the spectrum.
Assalamualaikum warahmatullahi wabarakatuh. So we continue for the D part, which is the operation of the FTIR. The first instrument is thermonuclear 380 FTIR. The operating instruction is enzymonic program was selected. Collect icon was selected and experiment setup was chosen to analyze the pellet. A data will appear in a window, shows number of scan is 32, resolution 4, final format, transmittance, absorbance, file handling, save interferograms, background handling, collect background before each sample. Save and OK was clicked. Collect was selected and collect sample was clicked. The title of the experiment was typed and OK was clicked. OK was clicked to collect the background spectrum. After the complete scanning, the pellet was placed into the sample compartment. OK was clicked to obtain sample spectrum. After the scan is complete, find pings and replace was clicked. Process was clicked, advanced ATR correction was chosen, GE was clicked, later OK was clicked. Analyze library setup, search was clicked to identify the compound. Lastly, printed and save the data. Next, the second instrument, which is Perkin-Elmer spectrum RX. Operating instruction. First shift scan, the silica gel was removed from the FTIR. The energy was checked. Stop was pressed when the energy is above 70%. Scan was pressed again. Background button was pressed, but the 3-time scanning was chosen carefully. Execute and scan was pressed. Background button was pressed and the sample holder was put on. The axis either X, Y, or Z was chosen. The screen will show like this background spectrum. Up, down, right, left arrow were used to modify the graph. The peak was marked. Shift V cursor or Shift H cursor was used. Shift mark was later used. Lastly, the plot button was pressed to print out the result. As for the unknown compound, we can assume it is the same as the cyclohexane compound because they have the same background spectrum. That's all. Thank you.
Okay, we will continue about discussion from our spectra that were observed during the KBR palette method. We could identify the functional group itself from the peak on the spectrum. For benzoic acid, functional group that been identified was OH that is stretched, usually very broad, which is strong H bond occur at 3400 until 2400 cm and often overlap at CH observation. COO, which is stretched broad, occur at 1730 until 1700 cm. Conjunction move the absorption to a lower frequency. CO as a stretch that occur in range 1320 until 1210 cm with median intensity, and C, which is the ring stretch absorption, occur in pair at 1600 cm and 1475 cm. Next, for acetone, functional group that been identified was CH around more than 3000 cm. CO stretch appear in range 1760 and 1670 cm. COH as a bending appear as a broad and weak peak at 1440 until 1220 cm, often occur by the CH3 bending. CO, that is phenyl alkyl ether, give to strong bonds at about 1250 until 1040 cm. For caffeine, there are more functional group that had been in here, which is conjunction of COO with phenyl at 1700 until 1640 cm for COO, 1600 until 1450 cm for ring C11CH. Stretch C11C occur at 1660 until 1600 cm. Often, conjunction move C11C stretch to lower frequencies and increase the intensity. CN, which is a stretch, occur in the range 1350 until 1000 cm, and CH, that was a bending, occur at 900 until 690 cm. For cyclohexane, CH was found, which is indicate stretch for sp3 CH around 3000 until 2840 cm and CH 2860 until 2800 cm. For polyphenol high density, which is plastic, the functional group that identified was CH, which is stretched for sp3 CH around 3000 until 2840 cm. CH, which is the bending rocking motion associated with 4 or more CH2 group in an open chain at about 720 cm. C stretch and CH2, which is a methyl group, have a characteristic bending absorption at approximate 1375 cm. Okay, we move to unknown. Unknown compound that were analysed using the FTIR was cyclohexane due to the same peak that was being shown as the cyclohexane wave number in the spectrum. We have errors on the experiment. First, the solution was spilled when dropping the solution onto the plates. Dropping the solution, make sure the solution does not spill and slowly work on it. The errors categorized as human error that need overcome during the experiment. For the second errors is do not use distilled water to wash the plate after each chemical test due to the sensitiveness of FTIR machine towards water. We must use isopropyl to clean the plate after each of the chemical had been tested.
For the discussion, Fourier transform infrared spectrometers FTIR offered significant advantages. The advantages offered by the FTIR are improved signal to noise ratio. Next, the faster acquisition of IR spectra. Next, superior wave number accuracy. By the meaning of accuracy, the FTIR helps to give an accurate wave number of the products that we use in this experiment. Next, and finally, the spectral information of all wavelengths is acquired simultaneously. The FTIR helps us save a lot of time. Next, in this experiment, 5 different samples were used, which is benzoic acid, caffeine, polyethylene high density, acetone, and including an unknown sample which provided by the operator used in this experiment. They were all analyzed on the KPR palette and reflectance method. Both these methods or techniques have their disadvantages, such as which the reflectance method uses liquid cells. The liquid cells need to be free of air bubbles. We need to get rid of air bubbles in the liquid cells. The liquid cells are also hard, very hard to clean. Next, the KPR, which is the potassium bromide, are hygroscopic, which it is very hard for us to handle or store. Makes it hard. Actually, the KPR makes it hard to make a good KPR palette without any experience or anything that this is the first time we used it in an experiment. It makes it hard to make a good KPR palette. It consumes a lot of time for the operation. The operation also needs to use the usage of special kit, which in this case we used the hydraulic press. Only a good operator with an experience can make a good KPR palette. Without any experience for us, it is very hard to obtain a good result. How can we overcome the disadvantages of both of the methods, which is the KPR palette and the reflectance method? To overcome the disadvantages of KPR pellets and liquid cells used in the reflectance method, nowadays IR measurements are mainly performed in ATR mode, which ATR stands for attenuated total reflection. As this technique is simpler to use than the conventional transmission mode. The conventional transmission mode is the KPR pellets and the liquid cells. All types of samples, such as liquid, solids, powders, pellets, or anything can be used in this ATR mode. The samples are placed and diluted on ATR crystal, which is the ATR crystal is the media for the ATR mode. The measurement really helps us, typically performed within a few seconds, really helps us in saving more and a lot of time, really a lot of time.
For the conclusion, we managed to prepare a KPR palette of benzoic acid by using 1:10 ratio for benzoic acid and KPR powder. The benzoic acid and KBr powder has been compressed by diesel and by using hydraulic press gauge. Next, we successfully carried out a qualitative analysis of benzoic acid by using ftir method. Lastly, the infrared absorption peaks and the corresponding functional groups of an unknown compound has been identified by comparing the result with the characteristic infrared absorption frequencies table. Thank you. That's all for our presentation.